In this next set, what we're going to do is look at some equations where there are multiple logs within the same equation, and we're going to have to condense them. Here's a list of the properties of logarithms. These are the same properties that we did that foldable on earlier, and we can either condense logs or expand logs. The problems that we're going to be solving here is going to require condensing logs. So if I see two logs that are added together and they're both positive, I can rewrite it as multiplication of the arguments. I can use the quotient rule. If I have a log that's negative, that means I can write it as division of the arguments, and the negative log is going to go into the denominator. And then there's the power rule, which we've sort of been using all along here, where I can write the power as multiplication of the log, or I can just put it in the power. So let's look at this teacher model. It's a little bit different because I have log base 2 of x times log base 2 of x minus 7. So now I really do want to think about condensing that log and how that would work. So I need to use those properties of logs. I see that we have addition of logs. So that means we can rewrite this as multiplication. So I'm going to start there. So I have log base 2, and I have x times x minus 7. I'm going to have to distribute that here in just a minute, and that's going to be equal to 3. It doesn't really matter the order we go to from here. Usually I like to distribute first, but it doesn't really matter. So I'm going to distribute that x inside of that argument to the x and also to the negative 7, and then I'm going to rewrite it. So I have log base 2 on x squared minus 7x when I distribute that x, and that's going to be equal to 3. Now, at that point, I want to think about trying to eliminate that log. So how can I rewrite the equation so that there's not a log in the equation? So I want to think about what my base is. My base is 2, and 3 is my exponent. So rewriting this, I'm going to write 2 to the third power is going to equal the argument, so x squared minus 7x. At that point, I can cube the 2, that's going to give me 8 equals x squared minus 7x, and I see that we have a quadratic. Now we know several ways to solve quadratics because we spent a whole unit on it. Now we can use the quadratic formula, or we could factor and solve for x. And there's a couple other ways. But before I do that, what I'm going to do is actually put it in standard form. Remember that standard form means that we get everything all on one side, and one side equal to 0. So that's going to require that I subtract 8 from both sides. So now I have 0 equals x squared minus 7x minus 8. I'm actually going to factor this because I can already think of two numbers that are going to multiply to negative 8 but add to 7. And so I'm going to bust the b that way. So I get x squared, and I'm going to bust it into negative 8x and positive 1x. So negative 8 and 1 are my two numbers that multiply to negative 8, but when I add them together, I get negative 7. So then, by grouping 2 and 2, I'm going to factor an x out of both those first terms, and that will give me x minus 8. And then in that second group, there's nothing really in common, so I'm going to take out a positive 1. That's going to leave me with x minus 8. So what that means is my factors are x plus 1 and x minus 8. It's a minus sign. So setting each factor equal to 0 and solving, so if I set x plus 1 equal to 0, I'd have to subtract 1 from each side, so that would give me x equals negative 1. And x minus 8, I'd have to add 8 to both sides. So my two answers that I have are negative 1 and negative 8. Now, especially when we have these resulting quadratics, we really want to check and make sure we don't have extraneous solutions, because these quadratic form ones do tend to generate extraneous solutions. So, real quick here, here's my check. I'm going to plug in -1 first, so I get log base 2 on -1 plus log base 2, -1 minus 7. These arguments, they need to be greater than 0. And notice they're not. So log base 2 on -1's not going to work. And that second one's going to turn out to be -8. And so that is not a solution. This is an extraneous solution. So I'm going to cross it out. And then I'm going to go ahead and check my other one just to make sure. Log base 2 on 8 plus log base 2 on 8 minus 7. And we're going to find out if that's 3. So remember, log gives you the exponent. So what exponent do I need to raise 2 to in order to get 8? Well, it's 3 plus. And then I have log base 2 on basically 1 after I do that subtraction. And what exponent do I need to raise 2 to in order to get 1? Well, it's 0. And 3 plus 0 is 3. So that does check out. Just remember when you're doing these that the domain of a log function has to be greater than 0. And so if you get negatives in your argument, that is something that's going to be an extraneous solution. Looking at the WeDo, go ahead and pause the video and try it yourself, and then play the video when you're ready to check your answer. When I look at this, I see that we have addition of 2 logs. That means I want to rewrite it as a single log. So I have log base 10, actually, because there's no number written there, so I know that it's log base 10. And I have x times x minus 3, and that's equal to 1. I'm going to go ahead and distribute that x to everything. So I get log on x squared minus 3x equals 1. And then I'm going to try to write this so that I don't have a log in the equation. So I know that my base is 10, even though it's not written there. So I have 10, and my exponent's 1, because that's what's on the other side of the equal sign. So that's going to equal what the argument is. So x squared minus 3x. I see that we have a quadratic again, which means that I'm probably going to want to get it in standard form. So I'm going to subtract 10 from both sides. I get 0 equals x squared minus 3x minus 10. I'm going to choose to factor this again because I can already see what numbers are going to work for busting the b. So let me rewrite this. I get 0 equals x squared. And then my bust the b numbers, things that multiply to 10 are 2 and 5. And if I want them to multiply to a negative number and add to a negative number, then my bigger number needs to be the negative. And now I'm going to group them 2 and 2 and factor out the greatest common factor. So they have x in common for that first group. That's going to leave me with x plus 2. And then in that second group, they both have -5 in common. That's going to leave me with x plus 2. So what that means for the final factors is x minus 5 is a factor, and x plus 2 is the other factor. And when I go and I solve each of these factors, setting them equal to 0, in that first one I'm going to have to add 5 to both sides, so I can tell that that's going to be x equals positive 5. And then the second factor here, I'm going to have to subtract 2 from both sides, so that's going to lead me to x is -2 and positive 5. Now don't forget to check for extraneous solutions. So here I'm going to check. I've got log on 5 plus log on 5 minus 3 equals 1. I'm actually going to solve this one in a slightly different way because it is log base 10. And when I think of what number can I raise 10 to get 5, it's a little bit more complicated to think about that. So I'm going to show you a different way to do it. So 5 minus 3 is 2. And I'm checking to see, is that really equal to 1? So I'm going to use the properties of logs again. When I have addition of two logs, that means I can write them as multiplication in one log. So 5 times 2 in one log. And then 5 times 2 is 10. So what exponent do I need to raise 10 to in order to get 10? Well, exponent 1. So that does check out for 5. Now I'm going to check 2, and I can already see there's going to be a problem because the argument of a log, or the thing that we're doing the log on, should not be a negative. It's not part of the domain. So this is not greater than 0, and that's not greater than 0. So that one is an extraneous solution. So we're not going to count that. Let's move on to the we do plus. Remember, pause the video, try it yourself, and then play the video to see if you got it correct. Here's the we do plus. I see we have 2 log statements, so I'm going to see if I can condense those into a single log. We're going to need to use the properties again. So addition is going to turn into multiplication. So I have x minus 1, and that's going to be times x plus 1, and that is going to be equal to 3. So I'm going to go ahead and FOIL that out. I get log base 2. X times x, that's going to be x squared. X times 1, so plus x. 1 times x is, negative 1 times x is negative x. And then negative 1 times positive 1 is negative 1 equals 3. And then notice we actually have 2 like terms. Those are going to cancel out because one's positive and one's negative. Alright, so we've got log base 2 of x squared minus 1 equals 3. And then I want to try to get rid of that log. Can we rewrite the equation so there's not a log? Yeah, we can, because there's my base, it's 2, and there's my exponent. So I have 2 to the 3rd power equals x squared minus 1. I'm going to cube that 2. I get 8 equals x squared minus 1. So at this point we could totally put this into standard form. You could try to factor it, or you might want to use a quadratic formula. It doesn't really matter. This is a case where I can actually use a different way to solve the quadratic, and that's only because there's no linear term. There's just that x squared term, so I don't have to try to round up 2 unlike terms together. So what we can do is just isolate the x squared in this particular case. So I'm going to add 1 to both sides. That gives me 9 equals x squared. And then I can just take the square root of both sides. I just have to remember to put plus or minus in front of it. So I get x equals plus or minus 3 for my answer. So now I just want to go back and check and make sure there's no extraneous solutions. So here's my check. Log base 2 on positive 3. So I'm checking positive 3 right now. Plus log base 2 on positive 3 plus 1. We're going to find out, is that 3? So I get log base 2 on 2 plus log base 2 on 4. Well, log base 2 on 2, that's like, what exponent can I raise 2 to get 2? I get 1 plus, and then evaluating that log, what exponent can I raise 2 to in order to get 4? Well, that's 2, and 1 plus 2 is 3, so that totally works. Now let's try the other one, negative 3. So I've got log base 2 of negative 3 minus 1. I know that's not going to work, so I could really just stop there. But actually the other one is going to be negative also. So not allowed. And so that negative 3 is an extraneous solution. So really my only real solution is x equals positive 3. Go ahead and try the you-do. Then go to the discussion. I posted a discussion page that is in reference to solving logs. So I want you to go in there and enter an answer about what you think went wrong and what advice would you give to the student. And lastly is the short comic about logs. After this, you're going to have to do your worksheet and your mastery ticket and then turn those materials in.